Alright, video lesson 5 is to help you in your for activity worksheet or homework question section B, question 2B. Okay, so section B, question 2B, question 2B. Okay, so right, let's take a look at the diagram. This is the diagram given to you. Alright, and there's a spring here. Okay, this is the spring. Alright, and this is the pivot. The black dot here is the pivot. Okay, and there's a mass. The weight is 80 Newton, hang here, so this is 80 Newton, and the distance between the mast object of 80 Newton to the pivot is 75 cm. Okay, and they tell you that this is a meter rule, and the weight of the meter rule is 10 Newton. So always remember, meter rule, the weight is always acting from the center of the meter rule. Okay, so remember, the weight is given 10 Newton. So where are you going to draw the weight? Always from the center of the meter rule. Okay, so this is the weight here, going downward to, this is downward to, so this is 10 Newton. So then the question is, what would be the reading if the rule is in equilibrium? Now, as you can see, this is your pivot here. So obviously there are two anti-clockwise moment, okay, produced. One is from the 10 Newton, two clockwise moment produced, clockwise, so because P is your center of the clock. Another clockwise moment is from here, okay, 80 Newton. Now, in order to find the reading of the spring, obviously, right, I'll use different color. The reading actually is produced from the anti-clockwise moment, right, which is from here, from the spring itself. Okay, right. So the spring will give you a reading, which is basically that will produce your anti-clockwise moment. Okay, now again, let's go back to our principle of moment. Right, the anti-clockwise moment is always equal to clockwise moment. Now in this case, you have to be more careful because there are two clockwise moments. And just remember, whether it's anti-clockwise or clockwise moment, the formula is the same. It's always force times perpendicular distance. Therefore, it's very important for us to find out what is the perpendicular distance for each of the forces that acted on the object. Now, from the spring itself, because we all know meter rules, the distance is 1 meter. Now, for the sake of the calculation, we can actually convert this 1 meter to 100 cm. So make sure all the units are the same. Alright, and then we also know from the 80 Newton to the pivot is 75 cm. What about the distance between the 10 Newton to the pivot? So we all know, right, 10 Newton is the center of the meter rule. So the distance here should be 50 cm. Okay, right, since we have all the information required, so what you need to do, you just need to fill in the blank. Okay, anti-clockwise moment is the force. In this case, the force we don't know, we try to figure it out, which is actually the question that require you to find out. But we know the perpendicular distance for in this case from the spring to the pivot. So you fill up the blank. Alright, And for here, clockwise moment, you have to add the two clockwise moments together to solve this problem. For example, for the first one, first clockwise moment that you have here is probably we start from the 80 Newton. Okay, so you have first one, the 80 Newton. Alright, then you multiply force, 80 newtons of force, multiply the perpendicular distance from 80 Newton to pivot. Okay, and then from there, right, you plus another moment here, and that moment is from the 10 Newton. Okay, then you multiply the perpendicular distance in this from the 10 Newton to the pivot. Okay, now from there you should be able to figure out the answer and find out what is F. Okay, let's try, and if you need further, not sure, I know have any problem, we will discuss this in next Tuesday.